Welcome, everyone. Thank you for joining us online. This is a session that is a cooperation between GSMA and the Global UTM Association, hence the title Aviation and Telecoms, where we're looking at the journey so far and where we go next in the cooperations. So please, we will go through the challenges that we have, but also we will talk about what we've done so far and what is next. If we go to the next slide, we'll go briefly to the agenda of today. So we will have presentations of our work task leaders. So we have 4 work tasks. And then we will have a panel discussion with part of the work task leader and our board of the ACJA. But without wasting any time, I wanted to start having a very brief introduction from the GSMA. So if we go to the next slide, we will show the work that we're doing in GSMA and the 2 different working groups that we have. One is called the ACJA, so the Area Connectivity Joint Activity. As I mentioned, is a cooperation together with GSMA and the Global UTM Association. And the other one is more looking at our membership. So we call it Run into the Group. On top of that, we will also have a variety of work that is happening for the foundation to work on, for example, the working groups, as we call it, regional engagement. And then we also have foundry projects, which is quite a new area. And then we have events and outreach for talking about the telecom and aviation. If we go to the next slide, I want to just let you see that we have a variety of different resources that are available on our website. So I suggest please go to the website and have a look. Also there you will find all the publications and the white paper that we're going to talk about today. So with this one, I want to hand my presentation. And I want to hand over to my correspondent from the Global UTM Association, Powell. Powell, I can bring you to talk about the Global UTM Association to the audience. Thank you very much, Powell. Over to you.
Thank you very much, Barbara. Pleasure to meet you all, and welcome from the Global UTM Association perspective. As a Global UTM Association, we gather really a broad membership. If we can move to the next slide. Across the globe, starting from the huge companies, ending with the members and the startups. So the message is that we are truly diverse and we are global, and that's why this is our strength. And thanks to this kind of initiative, like we have together with GSMA, we are able to influence together and shape the future of unmanned aviation. If we can move to the next slide, with my presentation, I would like to share with you why it is important and why we are here together with GSMA and what we are doing. And basically, what is happening right now is a transition from aviation, we call it 1.0, to aviation 2.0. Next slide. What does it mean? It means that you can transfer from the translate from the telephony perspective, that from the fixed lines you are moving to the internet, from the analog aviation, when you have a human-centric, human limitation, natural monopoly, and transport, we are moving to the digital world, where we have operation-centric, scalable, competitive, and drone services available. And within this, there are new challenges and there are new requirements. And together with such a partner like GSMA and other partners, GUTMA is working to shape the future and support stakeholders, companies, and organizations to jump into that train and be able to monetize and work with this Aviation 2.0 approach. Can we move to the next slide? So Within this transition, there are obvious that there are some limitation in human centric, and there are automations at the scale. So traditional aviation is focusing more on the human processes, where moving to the unmanned future and also automated future for the aviation, we need to be prepared for managing thousands of operations within an hour, to manage the UTM services, to manage connectivity, that it is a backbone for the automated operations. So all the activities behind that, like automated testing and, for example, big data and digital services, those are the new areas that came with the Aviation 2.0 and with the GUTMA and also with GSMA. We are aiming to shape and bring some framework and propose some kind of solution, how it could work, and also how and show some examples. And with the next slide, please. We want to show that the drone service creates values. So UTM gives in information for the safe flight. Drone operations, for example, flights from the hospitals to a place of accidents, drone delivery service, situation awareness, medical support victims, drone package delivery, etc. Those are the new areas of services that creates values for a whole economy. And if you can move to the next slide, please. Within those new values, there are also issues, challenges, but also opportunities. And within a GUTMA, we are working together inside GUTMA with our partners to try to tackle and solve and also predict some challenges and issue. One of the topics that we brought to the audience is where are the UTM service delivered? Effective competition in the UTM service market, innovative business models, or automated certification. Or we are discussing on create value drone service, and who is the final customer for the unmanned aviation. Those are the topics that inside Global UTM, together with GSMA and other partners, we are working to enable the future. I hope that within this slide deck, we show you a little bit glimpse of our perspective. If we can move to the next slide, that will attract you. And I want to say huge congratulations for the whole team of ACJA that since last more than 2 years works together to brought us to that place that we are here. And our colleagues and leaders will explain the amount of work that they've done to produce a fantastic deliverables. Within this, I want to say thank you and enjoy the live. Barbara, over to you.
Thank you, Pavel. Thank you for introductions and for the cooperation. So now we want to move to the actual work test. So the next one to present is going to be Boris Resnik, which is the CTO of Live City, and it is our lead for the work task 4. Boris, over to you.
Thank you, Barbara. Thanks for having me today. So I'm introducing the ACJ Working Task 4, responsible for interfacing with aviation standard development organizations, for liaisons with them, and for drafting operational performance specification. So next slide, please. So the most basic and probably the most important application of cellular technology for unmanned systems is a data link for the command and control capability. As I said, our primary responsibility is to interface with the aviation community. It was the task of Work Task 4 to enable this capability from the standpoint of aviation standards. So the work task, together with the help and support of other WTs, had drafted a basis for upcoming minimum operational performance standard for cellular command and control communications. This paper is expected to be published early in 2024 by EUROCAI and RTC as a joint global standard for cellular C2 communications. So, as the next step, WT4 has explored other ways to leverage new network capabilities. And the result was documented in a very recent deliverable named ACJA Landscape White Paper on US Solar Ecosystem. Actually, the paper is out today, and everybody is very welcome to review it. This paper it explores multiple ways how the cellular technology may serve the drones beyond command and control capability. Next slide, please. So, we as ACG community intend to use this white paper as a tool to identify our further scope. And this scope may include multiple things, such as UEV cloud controllers, which is a term that is used in telecom for remote pilot station, which is connected to the network. It includes things which are important for authentication and security. But further, we intend to, or we envision to develop new specification drafts, new MOPS drafts uh, for different capabilities beyond C2. That includes handling several implementations of remote ID capabilities, both broadcast based on aircraft to aircraft communications and network based on highly reliable air to ground communications. Further ahead, we will explore more advanced applications such as cellular assisted UTM services and detect and avoid or deconfliction capabilities. And another important task for working task 4 is to support harmonization between aviation, MOPS and MASP specifications and other deliverables of ACG. That includes network data and network performance specification developed by ACG Work Task 2. Uh, Details will follow today. And more cellular focused technical papers produced by WT1, which will form a basis for new 3GPP specifications in the future. So, using this mechanism, ACJ will ensure compatibility between telecom and aviation standardization. So, over to you, Barbara, and thank you very much.
Thank you very much, Boris, and thank you for the effort so far on the work task 4. And now we can move to the next work task. So we're going to have Stefano Faccin, which is the technical director from standards in Qualcomm. Stefano will only be on audio, but Stefano, over to you talking about standards.
Thank you, Barbara. Hello, everybody. You can go to the next slide. So I'm Stefano Faccina, I'm Director of Technical Standards in Qualcomm, and I'm chairing Working Task 1. So the work of Working Task 1 is really to interface with 3GPP in two ways. One is to, of course, develop ideas, opinions, and comments that we will then bring to 3GPP based on the work of the various work tasks. But the other one is also to identify how 3GPP tools can actually be used for the use cases that we have identified as relevant for the UAV and UAM use cases. So there are several tools in particular that are of interest, immediate interest. So the support of safety critical command and control communication for beyond visual line of sight, support of network remote ID, support of broadcast remote ID, and support of location tracking, monitoring, and QoS control for cellular connectivity. The first deliverable of the working group was on leveraging the 3GPP cellular network mechanism to support UAS operations. And the deliverable jumps into the detail of how existing mechanisms defined in release 15 and 17 can be used to support the use cases. So it's a form of introduction to these mechanisms at the high level, describing them, but it's really an how-to paper that describe how these mechanisms can be used, because of course they can be used and combined in different ways depending on the needs and the use cases. We have also created a UAS spectrum position paper that is being finalized, and it focuses on analyzing what are the spectrum needs for the specific cases of UV and UAM without jumping specifically in a recommendation for a band. I apologize for the typo. So we don't recommend any specific band, but we recommend what are the requirements for a bands that should be used for the use cases of UAV and UAM. Next slide, please. Now, we're working on a set of deliverables. So thanks to the work done in Boris' group on the ACJA landscape white paper that identifies, as Boris said, various areas and various components of the overall ecosystem. Working Task 1 now is focusing more on the details. And as I mentioned, it will highlight how 3GPP building blocks that exist or are being developed could actually be used for all of these. The idea is that we have here is the list of deliverables. So we will focus on the command and control connectivity service provider model based on 3GPP building blocks. Again, identifying what 3GPP mechanisms can be used, both for CS2P, C2 CSP that will be supported by an operator and not supported by an operator, so external. We are focusing on DAS solutions that are based on side link, so device to device, using what 3GPP is defining as aircraft to everything, A2X. We will work on identifying what tools are actually relevant and important and how they can be used for network remote ID and generating conspicuity, with a focus on transport, QoS, and security. And this would actually not define aspects that are more like at the application level, like the actual protocol being used, but it will focus on what 3GPP tools can be used to support this type of communication. The other two pieces of work, one we think is actually very important. So 3GPP system allowed to categorize the devices connected to the system for priority and QoS. And it's very important to understand what type of classification is required for UAV and UAM type or flights or mission categories, so that these can be fed to 3GPP to see how we can differentiate the connectivity between these different categories. And the last one, we will be jumping into analyzing how the 3GPP system operated by a service provider can actually supplement device-to-device type of solution for DAA and create a sort of DAA as a service that mobile operators can provide to UTM. And related to this, one thing just to mention, 3GPP, of course, has done a lot of work focusing on requirements for UAVs and has identified various use cases. And I think that the use cases that they focused are actually the traditional one, from package delivery to first responder use cases to infrastructure surveillance, and more generic to the UAM, without necessarily calling UAM, but let's call it people carrier type of scenario. So there is a large number of use cases that have been identified by the GPP that match quite well the same use cases that are being identified in the aviation industry. And that's all from Working Task 1.
Thank you very much, Stefano, and thank you for the introductions. I saw that there was a question coming in, but I presume you already kind of answered it. So the question was about what use case is standardized by 3GPP. I presume you covered it in your presentations and more so high level. But if there is anything you want to highlight, please let us know. You have a couple of minutes maybe to answer this question.
Yes, the 3GPP per se doesn't really look at the use cases of aviation, but what it does, it tries to understand what are the relevant scenarios where the 3GPP technologies can be used to satisfy the aviation use cases and identify requirements. So KPIs for the connectivity, or as an example for location tracking. And 3GPP really focuses on that aspect, define the KPIs, define the requirements, and then either identify how the existing tools can be used or define new tools. So that's the work. And as I mentioned, the use cases are pretty much the same that we've seen popping up everywhere in the aviation. So from the one that I already mentioned, from public safety, so like first responders like police and fire department, to package delivery, to infrastructure surveillance, to agriculture for rural applications, and transporting people. I would say UAV carriers that may be transporting goods and human beings on longer distances. Those are really the main use cases.
Thank you very much for that. Again, thank you also for leading this work. We will see you then later on the panel, so we
Sorry,
can
can I
go.
just answer one question very fast? I see there is a question on the timeline of the deliverables. Well,
Sure.
they will all be delivered by the end of the year. Some of them are more urgent because since Working Task 1 is aligning with the working 3GPP, we need to make sure that we have deliverables ready before the 3GPP works so we can influence it. So as an example, the categories one is probably the more urgent because if you want to bring requirement to 3GPP, we need to do it quite fast. I would say in the fall we should have all of them, but it really depends on the level of contribution, of course, and work. But my plan is to have all of these delivered at latest by fall. And if there is input from the industry on some of these being more urgent than others, we can reevaluate the priority and the time schedule of them. So input is very welcome.
Thank you, Stefano. Thank you again. So now we go to the next presenter. So we have the Work Task 2, Thomas Neubauer, which is the VP Innovation at Tioco, and also the co-founder of Dimitar. Thomas, over to you.
Hello, thank you very much, Barbara, for this introduction. As mentioned, my name is Thomas. I'm actually chair of Work Task 2, and you may ask, so how does that fit together? Well, we heard from Boris of Work Task 4 that we have the aviation side covered well, and we have the technology side on the telecom side covered well with Stefano's Work Task 1. So in Work Task 2, we are actually connecting those two. We try to define how the aviation systems and telecom systems can exchange data on the basis of the regulations and standardizations on both sides, and also how to actually better understand what connectivity in an airspace actually means. So based on that, next slide, please. The first delivery of what we have done is we have done a reference method for assessing the cellular C2 link performance and RF environment characterization for UAS. Think about it in a different way. If you could compare the gas consumption of two cars, the only way to compare the gas consumption of those two cars is by knowing the baseline, the reference on how is that measured. Exactly the same thing we do here for connectivity in the airspace. So with that, we actually have two components. The first one is for a dedicated drone, for a dedicated platform that is flying, where the drone is connected, the autopilot is connected in the C2 link to a cellular network, where we define the way to characterize the operational performance of a C2 link. And the second part is, without having a specific drone in mind, describing the performance of a cellular network in the airspace. So what that really means in terms of benefits is the first one is this provides a really harmonized reference method on how to set up a measurement campaign and a measurement methodology so that we can measure and characterize connectivity in the airspace. With that, we can compare apples with apples. So we can, if one mobile network operator measures according to this reference method the performance in the airspace, that mobile network operator can compare it with the performance of other mobile network operators and can compare it with the baseline. So they can answer the question, is my network actually performing good enough in the airspace to enable safe drone operation or not? That is an important point. Based on that, one of the things where we are helping is to understand, so based on what is achievable, what are actually the minimum performance requirements? Again, if we define thresholds for minimum performance, we also need to know how to measure that and how to characterize it. And that is exactly what we do. And last but not least, that is called the MOPS. I will come to that, the minimum operational performance standards. And last but not least, on that section, it is really about the possibility to benchmark the performance in the airspace. So if you're a cellular network operator and you actually leading the way, you can, utilizing those methodologies, demonstrate to your partners, customers, authorities, why you're actually providing a better performance in the airspace. That is what we do in this first deliverable, illustrated down at the bottom. You can download that reference paper from the GSMA and GUTMA web pages. Next slide, please. Equally important to understanding how to characterize it, it is also important to exchange data between the telecom networks and the aviation networks. And the reason for that is very simple, because the regulation for drone operation tells you that you must know before the flight where along the flight route you will have appropriate connectivity, because you will not be allowed to fly into airspace where you just do not have any connectivity. So there are thresholds for that. And for that, you need to exchange information. And that is why we have actually published the Network Data Service 2.0, which is actually a description of a harmonized description, harmonized in terms of globally harmonized with all the members of GUTMA and GSMA, to provide an interface for the data exchange between mobile network operators and the UAV ecosystem. With the exchange, we're covering all of that data that, for example, is not handled directly by 3GPP interfaces. I will come to that a bit later. So, and that is really an extension and an expansion of what we have been doing 2 years ago, which was called the Network Coverage Service. What are the benefits? What are the enhancements? Well, the title of the first publication 2 years ago, Network Coverage Service, already indicates that we were focusing on connectivity primarily 2 years ago. We have learned a lot and we've seen a lot of implementations in the meantime. So the first point is that version 2.0 does not only consider connectivity, but also dynamic data about people density on the ground, because mobile network operators know where people are, and that is highly important to actually assess the risk for BVLOS drone operations in a dynamic manner, so that it can be automated and so that the industry can actually scale. Furthermore, it provides the possibility to provide updates and monitoring capabilities for any changes that may happen to the network during a flight. Today, we see BVLOS drone operations that last for up to 4 hours with a drone without landing. So if you dispatch your drone and during the course of the operation, something changes to the network, how does the UTM know? How do you notify your flight that you have to actually potentially make a change to your flight operation? This is now enabled through the Network Data Service, where this notification to the UTM can directly provide it. Also, talking about the UTM, we are not limiting that anymore to the UTM, but we've learned that many other players in the ecosystem are actually interested in that data. Some of the data directly is interesting for drone operators. Other data goes to flight information management systems, common information services, and so on. Also, for those of you who are closely following the development of risk assessment, you've probably heard about SORA, the Specific Operation Risk Assessment, which seems to be the global standard for risk assessment procedures. And that will actually require dynamic data. At the moment, for ground risk, as an example, census data is used, which is static and tells you where people have been registered some time ago. Mobile network data can actually provide you dynamic information about where people are. And that is exactly what the aviation and UTMs and risk assessments are actually interested in. And with the network data service, we allow that exchange. And last but not least, it's about redundancy. We know that when we've learned that in many cases, depending on your ConOps, you need redundancy on connectivity. That can be with, different frequency bands, that can be with different deployments, that can be with different mobile network operators, or different even terrestrial and non-terrestrial. The network data service handles that as well. And at the bottom, just to illustrate that this is not theoretical, there are practical implementations. The middle picture just shows you something like an implementation at a mobile network operator, and the same picture on the right-hand side in a UTM system. So providing information as an additional data layer in a fully automated manner into the UTM system, connecting these two industries that did not have anything to do with each other. That's what we do in WorkTask 2. Next slide, please. So where we go from here, on the reference method, it is very important. So based on these measurements, the next step is really to collect a lot of measurements, because that is in close cooperation also with WorkTask 4 on the reference and standardization and certification aspects when it comes to the minimum operational performance standards. So we are trying to answer the question or help to provide inputs based on this baseline. What connectivity is actually good enough for a particular service, for a C2 with a specific environment? What is that? And we're gathering information, we are collecting information from many operations, from all the different stakeholders around the world, to provide input for that. That is one aspect. The other aspect is with the network data service. ACJA is not a standardization body. So what we do is we make recommendations to standardization bodies, and with the network data service 2.0, we're now moving that to the next level to make it a standardized API definition within the telecom community, and we're working with an organization that is called Camara, that is specializing exactly on that. That is a de facto standard, and providing that as an open source possibility so that everybody has the possibility to access such data. And secondly, obviously the aviation standardization and certification is required. We think in terms of like a wind and weather interface, and we are working with standardization bodies such as ASTM. Last but not least, the alignment with the 3GPP community is hugely important for us for the network data service. We see there are some requirements coming along, also in 3GPP standards for telcos to provide specific information. So we want to make sure that the WorkTask 2 service is actually coordinated with the 3GPP work, and therefore we work closely together with WorkTask 1 and WorkTask 4 on that. Thank you very much.
Thank you, Thomas. Thank you for the detail, and again, also thank you for the work you have done so far. and for the work that is coming for this year. So now I will actually present the work task 3. So apologies for our leader couldn't join. So I will represent what has been done and what is going to happen next. So if we go to the next slide, please. So what is that we have done in the work task 3? The work task 3 you can see as primarily of interest for the telco community. And this is something that, if you are coming from the telco community, is very important in order to maintain interoperability and to have interoperable services. We need to define profile. We call it service profile. This service profile is our, let's say, foundations. Particularly, it's work that GSMA has been doing for quite a lot of time to make sure that indeed all your services are able to run wherever you are. So the service profile, we started working on service profile for DLT based on the 3GPP standards. So we used everything that is from the 3GPP specification up to a certain stage. So we had up to the release 17, if I'm not mistaken. But we only, in this particularly paper, we only looked at the LTE, primarily because that is already widely deployed and the majority of the globally. So it's the foundation, so to say, to then continue to do the work for the other technologies. So from the initial work that we have done together with the ACJA, we then ask the GSMA working group, which are our long-term standing operational groups, to also take a look and actually see if there was any gap and to complete it to make sure that we have a full profile. So for all the, let's say, the interested party, particularly for the mobile operator, so we have the publication. The publication is available and is done. Is the recommendation is the NG 128. That's the document. So this document is pretty much important because that tells you how to. It covers, let's say, the recommendation for 3 different types of communication, which we classify as the critical communication, the non-critical communication, and also we have video and image streaming. These are categorized in a different way. Then could be some of the performances in the KPI obviously are reflecting the need and the performances that are needed for each of these type of communication. So this is as we are now. So if we go to the next slide, what is next? So as I mentioned, because there's a lot of work happening right now, any other work task, particularly as we saw bodies from the MOPS, which are the foundation also for the C2 link. But so we also waiting to see what is the result and see if we need to do any changes, adapting the profile, and also then further on we can utilize the profile for the work to be, let's say, transferred to also for the 5G technology. So this is, as the moment, the working task is, let's say, dormant, and we are waiting to reignite the work when it's required, when it's needed, when we have the outcome of the other working group. So this is where we have. So this was my last slide to give an overview for the working groups. So again, I want to thank all the work task leader, but also all the company members, both from the GSMA and the GUDMA that have been involved. It's been a hard work. Also for our listener, I apologize if there's a lot of terminologies that you aren't familiar, either because you come from the telecom or you come from the aviation. So bear with us, but if you have any question on alternate terminologies, we really recommend that you start reading some of the documents to get, let's say, a feeling of what we are talking about, but please feel free also to reach out to us. So now we're going to start the second part of the session, where we're going to go to the panel. Please feel free, if you have questions, to put it on a chat. We will try our best to pick up all the questions and see if we can answer it during the given time of the session. But with no further ado, I want you to introduce you first to Christina Pythora, because is my colleague from GSMA Intelligence. She's going to give you a brief introductions, and then she will lead also the panel. Christina, I want to bring you on for the presentation.
Thank you, Barbara. This is great work. And actually, this type of work has been inspiring us at the GSMA Intelligence, another part of GSMA, to work on drones or UAVs. Next slide, please. So I'd like to go over a few industry trends that we are seeing in the market. Commercial UAVs applications are gradually moving from the niche stage to commercial adoption through selected applications such as missions for emergency response, deliveries of sensitive and high urgency goods. We have been seeing this in countries in Europe like Ireland, Switzerland, here in the UK, also US, Canada, Japan, China, among others. Enterprise applications like the one you see in the bottom left of the slide. This is precision agriculture with precision spraying. So these type of applications now form high growing business segments for selected companies, such as key vendors of agricultural equipment. The necessary synergy between mobile networks and beyond visual line of sight missions are already and will continue to be in the focus of the ecosystem players and regulation for the coming months in order to get to the next stage, which will be about commercial deliveries and enterprise operations at scale. Finally, in addition to propelling applications growth, the proliferation of drones is also prompting regulators to rule to come up with clear frameworks as for UAVs operations. Next slide, please. I'd like to focus on 4 trends from the research we have been doing at GSMA Intelligence on the UAVs ecosystem, and 2 trends from the telecoms world. First, mainstream adoption of UAV services is largely anticipated in the post-2025 era. It's important to note here that this is a general picture that may not apply to individual applications and vendors. Furthermore, in reality, for any commercial launch to happen and succeed in 2 to 3 years from now, in reality, the strategy and the proposition has to start be shaping today. Second, there is growth happening despite the challenges pertaining to regulation, public acceptance, as well as technology maturity. Commercial deliveries appear to be growing at a double-digit rate. The UAVs market, on our early estimates, should be already in the order of double-digit $1 billion, and regulation is accelerating. Third one, applications come at different speeds with inspections, workers' assistance, delivery of selected goods, as I mentioned earlier. So these type of applications are taking priority, in addition to missions that are important for the public benefits, such as emergency response, which are also critical to get higher public acceptance. The sustainability imperative is perhaps less seen on UAVs players' radar at the moment, but it will likely very soon catch their attention, specifically in use cases such as environmental monitoring, carbon footprint offset, green infrastructure, and nature preservation. Fourth one, the UAVs ecosystem seems to have more clarity now on what's expected from mobile network operators. In addition to network support for airborne connectivity, UAVs identification, there is also the need for added value services such as database services, location verification, traffic management, telematics, payload, applications, streaming of video, and also leveraging mobile network assets and capabilities such as mobile edge compute and network slicing, which are particularly relevant with 5G Advanced that is coming up, and later on even with 6G. Now, moving on the telecoms world, drone support is emerging among the top interest areas for telecoms operators as for their 5G advanced network transformation plans. And finally, the vast majority of operators, I believe it was around 80% in our global survey, sees opportunities in drones, but in reality, only very few of them are clear about how to best position themselves and shape their strategies. Final slide. Next slide. Yes, thank you. So covering these topics in more depth, we are aiming to publish a report later in March. We will leverage two truly global and extensive annual surveys we run. One where we ask operators about their enterprise strategies, so telecoms operators, and drones, and their plans for drones and activity. The second one is where we ask telecoms operators about the network investment plans, things like drones priority in 5G advanced and for future investment plans in the networks. Finally, we have been working on a smaller but a more targeted survey of UAVs experts that is also feeding into that report work on wider UAVs market trends, challenges, and opportunities. So if you are interested, please reach out directly to me. And with that, I'd like to kickstart our panel discussion. There are some speakers that presented earlier, and there are also some new speakers who haven't introduced themselves so far. I'd like to ask them to do so. Let me also come on camera. Yes, so Leila, and then Chris and Peter, could you introduce yourselves, please?
Yes, hi, my name is Leila Ribeiro, and I'm with Matter Ingenuity, where I'm the technology director for the Open Generation Industry Collaboration Research and Development Initiative that, and our first area of focus is experimenting with drone use cases over 5G.
Thank you. Chris?
Yeah, hi, my name is Chris Casera. I'm a co-founder with One Sky and the technical lead for ACJA. I represent the aviation requirements for what we need from the cellular community. I'm also a commercial pilot, and I live in the DC area. Thank you.
Good to know. And Peter?
Well, hello, everybody. I'm Peter Musgrove from AT&T. I'm in the Standards and Industry Alliances group there. I follow a lot of UAV-related topics and a number of different standards activities, and very happy to be here today.
It's great to have you guys. Thanks very much. So let's do a round of questions because we have been collecting questions in advance of this. So I will be addressing some questions directly to you, but if you have spotted something from the questions that came live now and you feel strongly about it, let's make sure we bring that up. So the first question is for you, Peter. So it goes, from a telco perspective, is the work done by ACJA relevant for a mobile network operator, and why should that be important for a telco operator?
Okay, thank you for the question. Well, not only is it relevant, it's absolutely critical for operators, everything that's going on in the ACJA. You just heard from a number of people about the various publications that the ACJA has worked on in the past and that is working on for the near future. And I think it all goes back to appreciating how ACJA started. ACJA started to allow cellular and aviation people to learn to talk together, learn to try to come together to speak the same language. They tend to be very different areas. They have very different terminologies. Often they refer to the same thing with different terms. So just getting over the hump of introducing ourselves to each other, talking to one another has been quite a process, and it's ongoing. but it's very, very useful, and it's absolutely critical for mobile network operators to support this activity and to be involved if they're interested in this UAV space, which Christina, you showed earlier that many MNOs around the world in all the regions consider this a great opportunity for cellular networking. In terms of other reasons why MNOs want this, we've heard a lot about standards-based solutions to the problems here, and that'll be very important to continue to pursue because nobody likes proprietary solutions. Barbara talked about the LTE aerial service profile. That's one of the most important things for operators because it established a way to differentiate a UAV subscription from a normal smartphone subscription, and therefore to provide special features to allow for interference mitigation, for example, and other things to provide specifically for a drone in the air. So we're excited about those opportunities. I would like to address a question that Alexander asked about the 5G new radio aerial profile and what is going on or not with that. Well, I anticipate that ACJA will be working a 5G inter aerial profile after the 3GPP release 18 work to basically do the same enhancements that were done for LTE back in release 15. There's work in release 18 now going on to beef up NR to have those enhancements and a few others. So I anticipate it makes sense to do that 5G NR aerial profile in this group, either right after that work completes or maybe starting a little bit before that work completes. So I think it's important finally to encourage MNOs to participate in this activity, to make the dreams of BV loss communication or BV loss flights with drones and the whole UAS UTM ecosystem to come to reality. Thank you.
I also think that drones is something that our ecosystem, mobile network operators should be excited about. Thanks for this. So over to you, Pavel. So we have a question about, could you go through the achievements with the Global UTM Association and GSMA? So the work you have been doing together. And also, how do you see this collaboration realizing in 2023? I guess this means your plans, right, for the year?
Yeah, thank you for that question. So for the last more than 2 years, I think it was a very fruitful path for us as a Global UTM Association because thanks to that cooperation, most tangible result, despite of all the scientific work that was done in different working group, it is recognition by EASA. So all of the work that Thomas in Working Task 2 has done was mentioned in the EASA strategy 2.0. Like Thomas mentioned as well, SORA 2.5. Those elements shows that it was worth and we want to invest more. In addition to that, we can already share that there is extension in collaboration with EASA. There is an interest from EASA, from European aviation perspective, to even more invest in and focus on cellular connectivity. And from a global UTM perspective, this is a crucial element. Why is that? Because without the connectivity, UTM does not exist. Real UTM cannot scale up without a trusted and fully operational connectivity, and everything that GSMA and our panel of experts brought to this only confirms our strategy. And in regards of the plan for 2023, we don't want to slow down. We want to push forward. Like I mentioned, there are some activities with EASA. We are looking as well in advanced air mobility. So definitely, stay with us. Together with GSMA, we will announce soon what are the key elements that we will work in the upcoming year.
Thank you, Pavel. So the next one, I believe, is for Leila. So Leila, would you like to talk a bit more about the open generation focus and the UAS over 5G? So why 5G versus other telecommunication standards is the actual question.
Okay, thank you, Christina. Yes, so as I mentioned, we are focusing on experimentation. So what we are doing right now is trying to see how drones perform over 5G and how much better we can make it, right? So we have test beds, 5G test beds in the United States, and we are currently performing that experimentation. But I will first answer this question. I'll answer this question in two parts. Why cellular networks? Just the short. I mean, we talked about. We heard about a lot of the reasons. But basically, cellular networks are a natural choice for beyond visual line of sight operations. Because first, there is an existing network footprint, that's one thing, and over-license the spectrum, which means interference is managed, and the maturity of the 3GPP standards allows for us to rely on several capabilities that are already deployed. So today we're talking 5G, we may be talking tomorrow about 6G. And then why 5G specifically? There are several capabilities in 5G that benefit drone operations. Stefano already alluded to several of them, so I'll be short. The improved quality of service, including the antenna techniques for interference management and the service differentiation, which allows for safety critical versus high throughput, low latency, and in different scenarios of services. Network slicing, which allows us to reserve resources for safety critical, for instance, or for other C2 capabilities. Security built in from the 3GPP standards, including the authentication, authorization, device-to-device communications, which allows further supporting the detect and avoid capabilities. The computing at the network edge, which will allow us to do AI, ML processing at the edge of the network. And finally, private networks, which will complement or augment the service in critical areas where service is not available.
Thank you, Leila. That's very important. And as an analyst, I also took note of your testbed activity. I might be coming to you after this. So staying in the 3GPP, 5G area, question for you, Stefano. So looking at the standard, in particular 3GPP, what is happening that is relevant to the UAS domain?
Yeah, thank you, Christina. So there are various activities depending, of course, on the release. So in 3GPP, in release 18, we are building on what was done on previous releases. So in release 15, we added the LTE aerial features, the one that are actually now moved to NR, as Peter mentioned, as part of release 18. But in release 17, we also added a set of features that are being described in the working task one deliverable that allow mobile operators to better manage and identify these flying vehicles when connected to the network, to interface with the UTM for authorization, provide QS control. And we're building on top of this one in release 18 specifically to enable enable solutions for detect and avoid based on cellular PC5, and on how to enable also these side link technologies for applications like Procast and OTID. And we're looking at an initial version of some network-based detect and avoid as part of release 18, but that would be only just a little bit of initial part of work. Release 19 requirements are working more in details on all of these, and are defining requirements for redundancy of connectivity, for network-based DAA, for better interfacing between mobile operators and the external service providers. As an example, there, part of that work would be where we can standardize from the 3GPP side the work done by Thomas and his team. So there is actually a lot of activity in 3GPP on all of these, and the requirement part is still open. So if there is interest in ensuring that we can capture additional use cases or aspects that have not been identified so far, there is still time. Because the requirements from 3GPP SA1 release 19 will be closed by the end of summer, so there is still time to contribute to that. So there are several activities going on there.
Thank you, Stefano. I'm sure, looking at the questions that are coming up, I'm sure we will follow up on this. Let's take a kind of a different turn now. So a question for you, Chris. So integration of UTM in the aviation ATC standards, and how soon can we see that happening globally? What's your view?
Yeah, so One Sky is a UTM solutions company, and for me, UTM means cooperation, cooperative tracking. So typically in aviation, they rely on things like radar and ADS-B to transmit position. And this is new to have cooperative surveillance. And what it means is that we communicate our position over the telemetry. So if a drone is flying, it's being controlled by someone, and that position needs to be received and then sent to a system where we can manage all the vehicles in the airspace without having to put in this expensive infrastructure like radar. That's what UTM is. And I think the use of communications in LTE, I hope that allows you to understand how critical it is to have the communications, to have this backbone, and why the infrastructure of LTE is so important. So UTM, being the way that we want to see drones and control drones, needs to be integrated into the current ATM environment. And those projects are going on right now. We are involved in projects in Asia, like the FIMS activity in Australia. There's some upcoming activity in Singapore. We provide the capability for the Korean Grand Challenge that's going on right now to showcase air taxis and how they'll be flying in the airspace. And there's many countries in Europe that are implementing UTM, like the Netherlands, Norway, Germany, Sweden, Lithuania, and many others. So it's ongoing. And the standards are there to support the ANSP as well as the UTM companies when they go out and implement the capability. So we build our software to communicate with other UTM systems, but the ANSPs can also implement the same standards, and they can reach into the UTM infrastructure and understand what drones are flying and what they're doing in the airspace and control their activity, where they can fly, where they can't fly. It also allows us as ACJA to work in that same environment. So activity like Thomas and the work task 2, we can do things like look at the flight plan and understand whether you're going to have cellular coverage before you go out and fly. And that's important. So they are ongoing. I encourage you to look at ASTM from a standards perspective. And if you want to learn more about UTM, please reach out to me or talk to GSMA, and you can learn about other UTM providers that are building this type of solution. Thank you.
Thanks, Chris. We now have a very specific question about work task 2. I believe it's best for Thomas to answer that. So it's about the new release, the work you have been doing with the network data service. What drove the need of a second revision?
Okay. Well, it's the demand from the industry. Let's say 2-3 years ago, 4 years ago, when we started with ACJA, connectivity was not, a consideration in the top 5 points of priority. It was either considered a given or not important. Now, as we have a regulation, I give Europe as an example, where we have a use-based clarification, where we have easy access rules that define very clearly how you can actually deploy a BVLOS drone in future. And connectivity is a critical part of it. And it comes back to the legal aspect of a pilot in command. If you do not have a pilot in command, meaning if you do not have connectivity, you cannot launch a BVLOS operation. You will not get authorization for it. So therefore, it becomes now really important to actually provide that information ahead of the actual flight. So that is part of what has been driving that really from the connectivity perspective. And the other major thing on what we did on the revision was really with the ground risk aspect. SORA is specific operation risk assessment is now becoming operationalized, and it requires some more dynamic data. SORA 2.5 even has capabilities built in that give you a benefit if you have better data. And the best way to actually, and probably the only way to really get that information, is through mobile networks. So that means that we need to have interfaces that allow, in a standardized way, UTM systems, aviation systems, to get access to that data. And that is what led us actually to the revision. And the other point is, in these regulations, it is not just that you say, okay, I tested once. No, you also have to assure it. So you have to actually have updates on that. So it moved the connectivity and the ground risk. Generally speaking, the role of mobile network operators has been considered coming a lot closer to the aviation side. And because these two industries had nothing to do with each other before, there were no interfaces. And now there's a requirement to make it scale. And that actually really drove the revision in Work Task 2. And we're very glad that we actually got that out. And not only out, we also have that implemented now in multiple deployments around the world, apparently.
Thank you, Thomas. I think we have established that there is a need for the mobile networks to come as part of, as core part of the solution. We have been receiving some questions around whether it makes sense for them, like business-wise, whether there is opportunity and in what way. So I'd like to go perhaps back to Peter and ask you, Peter, so what would be maybe your suggestion to other operators that are starting to look at the UAS domain, where they should start? And I'd also like to bring up another question, maybe for you, Peter, Stefano, or whoever wants to come up. So reading from the audience, so MNOs, so mobile network operators, are used to dealing with tens of millions of subscribers in their planning and rollout moves. The UAS community, they might have an interest in using self-connected, see to the link, but would probably not exceed a few thousands today. What incentives would MNOs have to invest in the capabilities required to support UAS? So Peter, let's start with you about your suggestion to other operators, and you guys can take some time to think about our audience question.
Okay, thank you, Christina. So in terms of where I'd suggest other MNOs get started, in terms of the standards activities, standards requires a lot of learning at the beginning. So if an MNO is just truly getting into trying to understand the standards landscape, I would suggest going to not only the ACJA documents we talked about today, but there's other more sort of rudimentary places to start to learn more about the basics of UAVs. I know that there's a group called ANSI, the American National Standards Institute, that's published a UAS Standards Collaborative Standards Roadmap for UAVs. And their standards roadmap includes everything from, airframe requirements to information about inspections, personnel qualifications, technical standards from a bunch of different groups, including ATIS 3GPP, RTCA, ACJA, ASTM. I really think that starting off with the basics is a good idea in terms of a standard that I know Chris was advocating earlier to look at some ASTM standards. The ASTM standard on remote ID is one that I think is particularly interesting for folks to look at. That's the standard that is being used really in all regions of the world. It was not designed just for the United States. It was designed for all regions to handle the broadcast remote ID in particular, using Wi-Fi and Bluetooth technologies. Now, of course, in 3GPP, we're working on adding cellular to that. So I envision that in the future, the cellular PC5 kind of broadcast remote ID technology would make sense to add to that ASTM standard. And I think ACJA has a good role to play in that. So I think we need mobile operators to participate in this activity. Again, I can't emphasize enough the need for standards-based solutions in this area, and encourage participation by those MNOs to get the documents I just mentioned are good places to get started, as well as the other ACJA docs that we've talked about today.
Thank you, Peter. Yep. So going back to the audience question, maybe Leila or Thomas or both, would you like to,
Sure.
To say something?
So if I can address some of the commercial aspect here. We are working with Airborne RF with mobile network operators around the world. And essentially, mobile network operators for drones considerations have several possibilities. In general, drones are an IoT business because a drone can transport, practically speaking, three things. It can transport data, some sort of parcel, and sooner or later people. But it's done through the network, and as such, it is an IoT solution. And transporting data on IoT, the mobile network operators can make a choice. They can say, we want to sell connectivity for this IoT business, or we want to provide end-to-end services in one way or the other, or infrastructure and platform as a service. We all know that connectivity for IoT is not a phenomenal business case. That was the learning, I guess, over the last 10 years on IoT. Connectivity for IoT sucks. So the desire is actually to move up, because some of these drones are having very heavy business cases. They're replacing helicopters. They're generating something like 1 terabyte of data per hour. They need data hosting. They need edge computing. They have all sorts of other additional business value that is classical telecom services, if you look at it in a more abstract way. So what we see is telecom operators moving up the value chain and therefore looking at it. And no, you will sooner or later not be able to put in the cheapest SIM card into a drone and then fly with it, because you will have to authenticate for specific services in the airspace. So it's not yet another terrestrial user that just moves a bit higher. So it's a different business case. It's a different business, a digital airspace that has not been conquered so far, because there is, practically speaking, no real digitization in the airspace. It's not even limited to drones. It's, there are so many other capabilities up in this lower airspace that require broadband connectivity at low latency. And I think that is really the opportunity that is driving telecoms to actually look into this.
Thank you, Thomas. Leila?
Yes, I would just add some thoughts. I think Thomas provided a great answer. Looking to the future, I think that there is a great opportunity for this type of, cellular networks to serve more and more and even be enhanced by non-terrestrial networks at some point. So think of today, we are talking about beyond visual line of sight drones leveraging mostly the terrestrial infrastructure that exists. But as UAM, the air taxis are deployed and so on, and the needs go to the few thousands of feet, then we may see more and more opportunity for additional, let's say, expanded services as well. So I would say the incentive or the future is also into the possibility of how much this can expand from this type of service now and growing to these capabilities growing to the future to support other type of missions and use cases. And that lastly, I just want to mention that this can be actually serving even as this grows, it can be serving even crewed aircraft or the larger aircraft as well, which means that the existing communication, navigation, and surveillance systems get old, the legacy systems need to be modernized. More and more, the NSPs will be looking into leveraging commercial services, and that, let's say, that move to more ubiquitous type of connectivity is something that it starts with what we are talking about now.
Thank you, Leila. So, kind of staying in the same field. So, we have a question about network slicing. I guess this comes back again to the implementation and the synergy between 5G and drones. Do you guys have any thoughts? So the question goes: can we expect MNOs offering 5G network slicing wherever drones fly? And in how many years will drones be able to benefit from prioritized connectivity?
Well, Christina, if you don't mind, I'll jump in on that one.
Sure.
Stefano here from Qualcomm. There are two parts to that question. First, there isn't any network slice standardized at present that is specifically for the aviation vertical. So that is something that we need to consider. So we either will end up classifying, if we use existing the standardized slicing, the device as a generic multimedia device or a strict IoT device. And to tell you the truth, neither one of those really fitted 100% the requirements for drones. So as an example, if we had to choose one of the existing standardized slices, it would have to be considered a multimedia device. Because as Thomas mentioned, these drones use the connectivity for a variety of services. As an example, for many scenarios like surveys or public safety or even delivery, video is actually a very important component. And if you use pure IoT slices, you won't have video. So the first part of the question is, the answer would be that we either define a specific type of slice for this aviation vertical, or we reuse one of the existing one, and that is still an open question. But in terms of when it could be used, that really depends on the business model that would be decided between EOS operators and the MNOs that will support the connectivity for their UAVs on how to provide prioritization of resources, and slices could be deployed quite soon to enable that. So that can actually happen quite fast if we use one of the existing standardized type of slices.
Thank you, Stefano. Anybody else would like to bring up anything on network slicing and on the implementation side of drones with 5G?
I would just mention that this is part of our plans for experimentation in our 5G test bed. So we will be experimenting with network slicing as well.
Christina, can I also add an additional comment, because I think it's complement. Leila answered very well on why 5G with respect to others. The question I get asked also is, why are a lot of the features for UAVs and UAM being added only to 5G and not to 4G? And that comes down to two aspects: the standardization and the business. There is very little interest in the standardization world to keep enhancing LTE. and 4G. So most of the focus on new features, like for this aviation vertical, there is a lot of resistance to do standards work for LTE and 4G, because in the end, it comes down to who is really willing to keep investing on upgrading their LTE and 4G networks when they are deploying 5G. So a lot of these new features will actually be available only over 5G. That is a matter of fact, both on standard and a matter of investment.
Thank you, Stefano. Any points, guys? Otherwise, I think we can move on to the next question. So there is a specific question for you, Pavel, about the Global UTM Association and where can somebody go looking for current deployments and information for each country. So somebody is looking to understand the rules and the status of each country. So if you have any suggestion, and something also from the chat, are there any GSMA Global UTM Association led initiatives related to advancing autonomy of UAS?
Yeah, great question. So starting from the first question, so unfortunately, based on my knowledge, right now, GUTMA is the right place to address this question. So for the public users, as a global UTM association, we have developed a so-called map of UTM implementation. And within this tool, that is basically a map that we are pinning either commercial or R&D or national updates on the implementation. We are also putting an information on, for example, on the Europe level, on the implementation of use-based services per each country. So this is a first step that you can do to check where different countries are within this with the progress of implementation. But on the other hand, this tool is open and free to use for everyone, so every user can add his entry and put his information about his implementation of the UTM, and also information about the implementation on the country level. But going deeper, because I'm aware that this is like a high-level information. But if you are willing to learn about particular implementation per country, so I can only encourage to join GUTMA, because inside GUTMA we are analyzing all the data across the globe, starting from the USA, and thanks to the collaboration with NASA, with FAA, and with our business partners and our members from that part of the globe, through Europe and our cooperation with EASA, Eurocontrol developed a report that we are also analyzing and making our assessment, because unfortunately there is a lots of data available on the market, but unfortunately they are self-declared. What does it mean? That means that, you know, there are often this kind of situation that on a country level they need to declare their progress of implementation of the use-based, for example, program, and they are declaring that they are progressing, but the reality is a little bit different. So what we are doing inside Global UTM Association, through the network of our members and our internal work, we are analyzing whether something is really progressing, and we are giving this kind of feedback and recommendation and insight to our members. Regarding the question about the
autonomy.
The autonomy.
So, any initiatives related to this one?
Yeah, so a very good question, a very detailed question. To be frank, there is no strict initiative on a GUTMA side that we are focusing in that area. But on the other hand, we have a very advanced standard harmonization working group that we are working and analyzing existing standards and making recommendations for the next stages and for the community and the SDOs. And also this type of analysis about the advancing autonomy is as one of the chapters in that white paper. This is still in progress, so I encourage you to track and trace GUTMA publications. I hope that we will be able to provide some input how this looks like from the standardization, or maybe from the, if it's not covered, what are the expectations in that area.
I can talk a little about the autonomy if I have a second.
Yes, sure, Chris. And guys, since we are coming up towards the close, can you please think about like a few seconds of parting thoughts? Let's make sure that everyone speaks in our final round. But Chris, you have a minute for sure.
Yeah, autonomy can come in many different flavors, I think, with drones. And so there's autonomy within the UTM in terms of how we do things like authorizing flights and understanding where they can fly. And so what we try to do is automate the rule sets behind the scenes. So where you would normally request from a person a clearance to fly, now you have a system that can do that in an automated way. So that's one way autonomy can be deployed. Another one would be detect and avoid on board the drone. And there's been a lot of work with things you might have heard of ACAS or ACAS SXU. That's work done in the US, but I think it's a global activity, and it allows us to provide a safe separation from drones and other aircraft, manned aircraft within the drone itself, and also within a UTM system. So there are activities that help, that we're advancing to help with the autonomy. But there's a lot of autonomy in drones already, and I think what UTM does is help to keep that autonomy in check.
Thanks, Chris. So guys, any final comments, any parting thoughts? Feel free to open the mic before we wrap up. Thomas? Oops.
Sure.
I was just going to say one more thing, and just that, you know, we've been talking a lot about drones, but there's other use cases for low-level cellular, and we haven't really talked much about econspicuity. That's a big activity in Europe, which will engage the cellular for manned operators. So just thinking in a different perspective can help you with your business model.
Thank you, Chris. Thomas?
I would like to give a big applause to GSMA and GUTMA, because as somebody said, the future belongs to those who see things before they become obvious. And I think now it's time where it becomes obvious that cellular and aviation have to go together in order to scale in a safe way and integrate the digital airspace and aviation. So GUTMA and GSMA, you're doing that now for more than about 4 years. Great work, and I think it's a pleasure to actually participate in that and contribute.
Thanks, Thomas. Leila?
Yes, I would just like to echo that and say that I see the role of ACJA with GUTMA and GSMA, what is being done here as like accelerating a virtual cycle. I think that the three elements, the partnership across the aviation and wireless industry are important. For being able to provide information that informs regulatory aspects that will expedite the operations, and also to inform standards. I think all those three elements are very important, and I see all of those being touched. So I'm really happy to be joining part of this effort.
I see Barbara is back. I guess our time is up, right?
Correct. So we're running out of time. So I just want to thank you all for being part of this panel, for being part of the work that we have done so far. It's been very long, difficult, but is useful. I would really say that it opened up a door for all of the two industry to look at this area. So I will really please all the participants. Feel free to contact us, go on the website, read the informations. We have more information available for you. But also, if you want to see these slides and the replay the session, will be available on LinkedIn for a while, and then will be also posted on our website. So again, thank you to all of you. It's been fantastic. So join us for the next time on the live. Thank you very much.